All right, sorry for being a little late. I was trying to get some homework done for my roommate. Uh can everyone hear me well? All right. All right, so my game plan for today is to kind of do what we did last week with the Taylor with series, and we just go through some. We essentially have this be more of a problem solving session. Uh, so for yes Zoom meeting, I'm going to assume that y'all have seen the video for section 11.1. And so I'm just going to spend today kind of having us get our hands dirty with some problems about approximating stuff and finding an estimate for the remainder. And that's going to be my game plan. And to kick it off, here's going to be the first problem I want to ask y'all to try to do. So I want you to find P1 and P2 of x for the function f of x equals 1 over x. And I want you to center that at 1. And with that information, use this to approximate value 1 over 1.05. All right, so essentially what I'm going to ask y'all is find P1 and P2, and then use your answer for P1 and P2 to approximate the value 1 over 1.05, or to go with our function to approximate our function f at 1.05. So that's going to be the first problem that I want to give y'all a few minutes to work on. We'll give y'all till about 3:42 p.m. Eastern Standard Time to work on that. If y'all have questions, post them on the chat. And if you think you have an answer, also post us on the chat too. um, so you need to clarify. I just want y'all to find P1 and P2. And so I want only the first and second order Taylor polynomials from y'all. And then I want y'all to use those two polynomials to approximate 1 over 1.05. I'm to the best of us unique. For those of you who just joined in, I want y'all to work on this problem that I stated. We'll get a few minutes. Do you mean in terms of, for your question, AJ, do you mean in terms of the Taylor polynomial expression or when you evaluate what I want to approximate? If it's the former, then I say leave it as, okay, yeah. If it's the former, then I would say don't really simplify because it'll just be nasty as is. So I would just leave it in the form that we have. You're welcome. Give you all about 2 more minutes before I go over the solution. Alrighty. All right. With that, let's go over his problem. So, quick poll from the audience. What did y'all get for the first order Taylor polynomial? For the expression. All right. Anyone else? Anthony got his answer up? What about other people? Kind of want to pull how people did this problem. All right. All right. So Aiden and Unique have the same answer. Because Unique, yours is just plugging in the formula and Andrew decided to simplify it. But you both have the same answer. So go ahead and tell you that I agree with both Andrew and Unique, and let's figure out why. So recall that the first order Taylor polynomial is of this form. And since a equals 1, that means I'm going to plug 1 in for f of x, which means f of a will be 1. Keep in mind that for the first derivative of 1 over x, or x to the negative first power, it's negative 1 over x squared. So if I plug in the center, which is 1, so let's go ahead and plug a 1. Get negative 1 over positive 1 squared, so negative 1. That means I get for my final answer 1 plus negative 1, x minus 1. And then if I want to simplify, I could distribute the negative 1 to the x of the 1 and they combine like terms. And I'll get 2 minus x in my simplified form. So there's my first order Taylor polynomial. So any Unique, you both got that one right. Anthony, you were a little off from that. So just want to keep that in mind. Fair enough. That's why we're doing problem sections, to make sure that we're all on the same page. All right. And like I said, during the middle of this, if y'all have questions, interrupt me via the chat. So for the second order Taylor polynomial, what did y'all get for that? Keep in mind that you now know the first order Taylor polynomial. So you already know that brand new stuff. All right, Chigel gave me his answer. Anyone else? Hmm. So I claim, Anthony, that the second half of the answer, the two will go away after simplifying, and let's see why. Second derivative at a over 2 factorial, which is just 2, x minus a, and since a is 1, I'm going to replace a with a 1. That we already know from our first order Taylor polynomial. We know that that's 2 minus x, which means we need to calculate that guy. And now let's go ahead and calculate the second derivative evaluated at 1 divided by 2 factorial. So second derivative of x, since I already know the first derivative, I'm going to just take the derivative of the first derivative, and then by power rule, I'll get 2x to the negative third power, or 2 over x cubed, which means evaluated at 1, I get that the second derivative evaluated at 1 is 2, which means if I want to simplify that, evaluated at 2 factorial is 2 over 2, and that simplifies down to 1, which means my second order Taylor polynomial is going to be 2 minus x plus x minus 1 squared. And so I saw some stuff on the chat. So Anthony, you're technically right. I am dividing by 2, but because my second derivative evaluated at 1 equals 2, the 2's cancel out when I do the simplification. Alrighty. And with that, let's go ahead and figure out how good our approximation is at 1.05. So when you plug in 1.05 to the first order Taylor polynomial, which we now know to be 2 minus x, what value did y'all get? There you go. I agree. 2 minus 1.05. After doing that work, we get that our approximation is 0.95. What about our second order Taylor polynomial approximation? What did we get of how good of an approximate we got if we plug it into our second order Taylor polynomial? Yep. And when you do these calculations, let's pretend that this is the final. Or better yet, let's pretend this is test 3 before quarantine, where we can't use our calculator. Let's see how we can calculate this guy. So again, Taylor polynomials always build off of each other. So I can always use my previous information to help me out here. I already know my first order Taylor polynomial equals 0.95. But now I'm adding my brand new stuff, which is to 0.05, all of that squared. 5 squared is 25, and since there are 2 decimal places, that means 0.05 squared will be 0.0025, which is how we would get 0.9525. If say we're not in quarantine and we were taking test 3 and that was our problem. All right, so before I go on to another problem, do y'all have any questions about this example or any questions in general? Type your answer in the chat below while I take a sip of my coffee, which is a proud sponsor of this Zoom meeting. All right, going to assume that you don't have any questions. So I'm going to post another problem that's similar to give us warmed up. Here's the problem that I want to give y'all. Yeah, that's good. Find P3, P4. Oh. Center that guy at 0. And our function now is 1 over 1 plus x to the negative to the 3rd power. This is more of a warm-up for us to know how we can calculate our Taylor polynomials. And for this, I'm going to recommend don't use quotient rule because quotient rule sucks. So yes, I'll recommend to use chain rule here. Give y'all a few minutes to work on that. And if y'all have questions, let me know. I'll give y'all till about 4:02 to work on it. Again, if y'all have questions, work on that. See some messages on the chat, and I'll respond to those shortly. Technically, yes, Isaac. In order to know the third and the fourth Taylor polynomial, um, you essentially do have to know the first and the second Taylor polynomial, since they're going to build off of P1 and P2. Sweet. I'll give you all two more. I'll give everyone else 2 more minutes. Alrighty. So passed. So quick poll from the audience. AJ, I saw your message, and you can. And let's finish this problem. Then you can ask a question about the take-home quiz. So quick poll from the audience. What do y'all get for the third order Taylor polynomial for that problem? All right. Hugo posted his answer. Anyone else? Okay. Thanks for your added detail, Isaac. All right. All right. So Unique got similar answer, but a little bit different. And also Unique, where's the ats in your 3 ats? Yeah. All right, so I'll go ahead and state that I also got the same answer that Unique had after simplifying. Let's go ahead and figure out how we got that answer. So to do this problem, I do need a couple of information. I'm gonna list out my f. No, you're good, Andrew. Like I said, that's why we're doing these problem sections. The first derivative, second derivative, third derivative. And for yets, I'm also going to go ahead and calculate the fourth derivative because I'm going to need that for the fourth order Taylor derivative. So that one's pretty quick. What did y'all get for the first derivative of the function f? Good. Like I said, leaving it at form. And now we could do essentially power rule with the chain rule with the power rule. Get -3, 1 plus x to the -4th power. Oh, Isaac, I saw your message and I agree with you on that. So let's go through with that. So with that, nice thing about the second, third, and fourth, just going to keep doing power rule over and over again. So I'm going to get 12, 1 plus x to the -5th. Power rule again to get -60, 1 plus x to the -6. And then -60 times -6, which is 360, 1 plus x, -7th power. So yeah, we got 360 no scope. And now plug in our center. So that means wherever I see an x, I'm going to plug in 0. Plugging in 0 there just gives me a 1. Plug in 0 in the first derivative, I'll get 1 plus 0 to -4, which is 1. So I get -3. Plug in 0 for the second derivative, I'll get 12. Plug in 0 into the third derivative, I'll get -60. And then plug it into the fourth derivative, I'll get 360 again. All right, and now we're going to calculate third order Taylor polynomial. So f at the center plus the first derivative at the center times x minus 0, or the center, plus the second derivative at 0 divided by 2 factorial x minus 0 squared, plus the third derivative at the center divided by 3 factorial x minus 0 cubed. Cheagle, you already let me know how you got 6 for the third, but let's go over everything. Got -3 after that operation. Because second derivative at 0, I get 12, and divided by 2 factorial, which is 2. That goes down to a 6. And because the third derivative is -60 and 3 factorial is 6, I get -10, which now gives me that my third order Taylor polynomial will be 1 minus 3x plus 6x squared plus 10x cubed. Or minus 3x cubed. I can't read. And boom, there we go. And now let's go on to the fourth. Isaac, I'll go ahead and let you know that you got the same answer, that you got the correct answer for that. But let's go over it. Remember, Taylor polynomials always build up. So I already know my third order Taylor polynomial. So now I'm going to add the fourth derivative at 0 divided by 4 factorial. We got that the fourth derivative at 0 is 360. The 4 factorial is 424 when I evaluate. 24 goes into 360 15 times, so that simplifies down to positive 15. Meaning that my fourth order Taylor polynomial is 1 minus 3x plus 6x squared minus 10x cubed plus 15 x to the fourth. And there goes my final answer. All right. So there's our third and fourth Taylor polynomials. Any questions so far on how to do this or anything? If not, AJ, I could go ahead and answer your question on the take-home quiz. And while you're typing out your take-home quiz, I'll go ahead and write down the next problem that I want y'all to work on. Oh, sorry, your question, AJ? Yeah, that's fine, AJ. If you need, and to justify that, you can say that e to the x is an increasing function. So that means since 1 is less than 3 halves, e to the first power is less than e to the 3 halves. All right, you're welcome. Glad to know that y'all are working on the take-home quiz. So now my problem is use the third order Taylor polynomial to approximate what's a good one? The fourth root of 79. So keep in mind here that I did not give you the function f of x, nor did I give you the point to center it at. So that's going to be up to y'all to figure out. So while working on this example, determine what f of x is, and also determine where you want to center that Taylor polynomial at. And yeah, Nick, you're exactly right. Usually the question for f of x is going to be quick and easy to pick because it just asks what function is being used in that case. Not quite, Anthony, because it's not 3, because fourth root of 3, I don't know what that is. James and Andrew, I agree. I would pick 81 in this case. And the reason why, because I want to approximate 79, just like with linearization, I want to pick a number that's really close to 79, but I also know very quickly what the fourth root of that is. Oh, I get it, Anthony. You went ahead and took the fourth root of 81? Yeah, okay. Yep, okay. So yeah, and let me make that note. Because it's easy to calculate, and 81 is close to 79. All right. Since y'all now know what f of x is, and you know what a is, go ahead and work on the third order Taylor polynomial. Since y'all got the hang of it, I'll give y'all until like 4:20 p.m. to work on it. Damn it. That made me giggle a little bit. Like I said, y'all have a question, just post it on the chat. Take a sip of my water. Sure, that's fine. I mean, I can't stop you from using a calculator, Anthony. All right, I'll give you all another minute. Oh yeah, that's definitely something the FBI cares about. When I use my calculator while doing the problem. Wonderful. Yeah, 84 for English SAT. Oh man, I'm going to calculate how to define a word that I need to use. All right, let's bring it back to perspective. What did y'all get for the third order Taylor polynomial for this problem? Uh, Wonderful. So going back on topic, what do y'all get for the third order Taylor polynomial? Well, at least you're honest. I agree that it's going to be a little bit ugly for this problem. So since it's going to be something ugly, let's go step by step, and I'll kind of ask how it's going from there. So, third order Taylor polynomial. Need to know my function f at the center, which is 81. Need to know my first derivative at 81. First derivative, s minus 81 squared plus second derivative at 81, 2 factorial, s minus 81. Oh, Scott, what are you doing? You can't read today. Plus the third derivative at 81, 3 factorial times x minus 81 cubed. All right, let's see why this is going to be super ugly and nasty. Well, f is not too bad. That's the fourth root. What did y'all get for the first derivative of the fourth root of x? For the derivative of the fourth root of x? I know what you mean. That's what I get when I plug in the fourth root of 81. Yeah, I got it. All right. Alrighty, so let's go ahead and put that down. To make it clear how I got f over 1 over 108, if I took the first derivative, I'll get 1/4, x to the negative 3/4. And let's see how nasty that's going to be when I try to calculate that. 1/4, fourth root of 81, and that's going to be cubed. You know, fourth root of 81 is 3. 3 cubed is 27. And 4 times 27 gives us the 108. All right. And now here's where it's going to start getting a little bit nasty. Go ahead and write out the expression for the second derivative. I got that for my second derivative by using the power rule. What will I get when I plug in 81 to my second derivative? Yeah. Well, that's fair. All right. And I agree. Like I said, this is something that will not be on like a test if we weren't in quarantine because these numbers are ugly as is. So let's go ahead and finish this problem. So if I do the third derivative now, That's what I get for their derivative by using power rule. What do I get when I plug in 81 to my dirt derivative? Yeah, that very nasty. The one thing I don't necessarily agree with Anthony is I don't think we should have a negative sign. Because when I took the third derivative, the negative sign for the -7/4 should cancel with the negative sign in front of the -3/16. So I believe that just should be 21 over that very nasty number. So I don't think we should have that negative sign there. But with all these nasty numbers, let's plug it in and get that our third order Taylor polynomial is f at 81, which we now know is 3, plus our first derivative at 81 divided by 1 factorial times x minus the center, 81. So 1 over 108 times x minus 81. Repeat that for the second derivative. -3 over 34,992 divided by 2 factorial. So I would get minus 3 over 2 times 34,992 times x minus 1 squared plus the dirt derivative if you have it at 81, 21 over this whole nasty number multiplied by 3 factorial, which is 6. That should be 81 times s minus 81 cubed. And like I said, you could simplify it and make it look neater. But this is already nasty as is. So I say simplifying is for suckers in this case. So for the Atzner-Taylor polynomial, for a yes problem, since our goal was to approximate the fourth root of 79, I would now plug in 79 because our whole goal was to approximate that guy with the third order Taylor polynomial. And so if our question was approximate blah, as soon as I'm done with all of this work, plug in 79 to our Taylor polynomial, and that'll be our approximation of the cube root, oh, not the cube root, the fourth root of 79, which when I did it, I got about 2.9813, blah, blah, blah. Actually, 1, if I rounded it. which makes sense, mainly because we know that the fourth root of 81 is 3, and the first derivative is a positive, will give me a positive number for any x value in its domain, which means the fourth root is increasing. So it makes sense that the fourth root of 79 should be some number less than 3. All right. If y'all have any further questions on this, interrupt me in the chat. Otherwise, now I'm going to throw in a problem where I'll have to use the remainder. Here's going to be the first question with the remainder. I think this is problem 4 that I'll be doing. Yeah, this is 3. So it's going to be 4. So you just want to get us warm up for the remainder. Write out the expression for the remainder, where the function is let's do, yeah, like that. Cosine of x. And my center is pi over 2. I'll give y'all until 4:40 p.m. to work on that. If y'all have questions on the chat, let me know. But the goal right now is to write an expression for the remainder with that function. And if y'all think you got something, just post it on the chat. Or if you have a question about that problem, also let me know. All right, give me a status report, y'all. How's that problem going for y'all? All right. Fair enough. So the goal for yes problem is to use the theorem from the notes. Called Taylor's theorem. And essentially what the main portion of Taylor's theorem tells us is it gives me an actual expression for what the remainder should be. It is the nth plus 1 derivative of f evaluated at some point c divided by n plus 1 factorial times x minus the center n plus 1, where c is some number in between a and x inclusive. That's going to be, yeah, so unique. One caveat I have with Taylor theorem and why I'm going to talk about later, why we care about estimating it. That's going to be kind of our hiccup with that. Cool. I know an actual expression for the remainder. That part is, what's that value c? So all I can tell you for an expression for the nth order, or for the nth remainder, is that it's going to be the n plus 1 derivative of cosine of x evaluated at c divided by n plus 1 factorial times x minus the center, which is pi over 2 to the n plus 1 power. And that's about all I can tell you with that, which is not really useful in terms of actual application. Well, even with the final answer, I claim that C is still too difficult to find, and that's because C has a lot of variability in there. So one example, let's say C was standard for 1 to 2. Well, I have a lot of choices there to choose for that value C. And too much numbers to C where I don't like that, and so we have to go better than that. Which is why the next part of the game, there we go, is trying to estimate the remainder. How true is that? The reason why I made that comment unique is when I was an undergrad, I minored in chemistry, and that was something that annoyed the heck out of me, like a lot. So I understand. All right. And so now the next question is, in how we're going to talk about the error or the remainder, is how do I estimate this guy? Well, if I know This is bounded by some positive number m. Then I win because I can now bound my remainder in absolute value by m absolute value of x minus center factor n plus 1 divided by n plus 1 factorial. And that's going to be our main idea of how we try to find that guy. How to estimate the error for that. And using that, let's go through an example of us doing that. In this one, I'll actually walk through a little bit more, and that's because I think estimating the remainder is the hardest part of section 11.1. And so I want to finish up our estimating by me going through one example and then giving y'all one to work on. So here is going to be my dot process. So let's find a problem where it's good. So yeah, I'll do yes. So let's say our function is sine of x, and I approximated with the third order Taylor polynomial. For yes, I'm going to go ahead and write out the third order Taylor polynomial. And I'm going to go ahead and say I am working in the interval negative pi over 4 to positive pi over 4. And so now my next thing is, how do I calculate that guy? So first thing that I'm going to list out, I know that n is 3. I also know that a yeah, that's good. Yeah. So now I'm going to say that I'm now working in the interval negative pi over 4 to pi over 4. And so in this case, I'm going to let a be 0, or not a be 0. Yep, a be 0. And that seems weird because I'm working in the interval negative 4 to positive 4. And so now the question is, now why did I choose that to work with instead of another guy to work with? And so I'll address that question, your comment later, Unique, but I'll walk through this example first. So the idea why I chose a to be 0 is mainly because the interval I'm working with is symmetric. And so because of that, I'm picking the exact center of that interval, which is a equals 0. So the main reason why I'm choosing my center for my approximation to be 0 is because I'm working in a symmetric interval, which I mean is my endpoints are the same, they only differ by a positive or negative sign. And then our f of that is sine. All right. So first let's talk about general form for that Taylor polynomial. I know that I'm going to have set that equal to the fourth derivative of the Taylor polynomial at c, n plus 1, since n is 3, 4 factorial, times x minus a, which is 0, to the fourth power. Now, what I'm going to have to do is I need to satisfy this condition and figure out what that's going to be. And typically, the strategy is to figure out what to bound the n plus 1 c to pick m. Is to essentially ask yourself, what's going to maximize that guy? So in the interval negative pi over 4 to pi, or in any interval that we always work with, we need to figure out what will maximize it. And the way to figure that out determine if that function increases or decreases. And the reason why I say that, if it increases, we're choosing the right endpoint. Because if that is the case, then I can just bound yes by plugging in the right endpoint, because I know all values will be smaller than that guy. And vice versa, if I realize it decreases, my typical strategy will be choose the left endpoint once I know I am decreasing, for the exact same reasoning. But for this example, I say I don't have to do neither, because since my function is sine, my fourth derivative, or my fifth derivative, when I plug in sine of x, is cosine. And I should use c to note that is the value c. And because that is inside the absolute value, I note that sine and cosine cannot exceed 1. And I don't care what value for c I choose, that can't happen. And so because of that, that will be my m equals 1. And so now I can say I'm going to estimate my fourth order Taylor polynomial, or the remainder of the fourth order Taylor polynomial, which equals fifth derivative of f at c over 5 factorial times x to the 5th power. That is going to be less than or equal to. Now I'm going to replace the 5th derivative at c with m, which we determined to be 1. So 1 over 5 factorial. And what I'm now going to do to plug in for x I'm going to plug in pi over 4. The reason why I'm plugging in pi over 4 into x is because in that interval negative pi over 4 to 4, I claim that s to the 5th always increases. And the reason why is if I take the first derivative, I get 5x to the 4th power, which means I increase from negative pi over 4 to 0. And I also increase from 0 to pi over 4. And the reason why I am excluding 0 is because that's my critical point. And when you evaluate that, I'll go ahead and tell you right now that you're going to get a nasty number. And it's 2.49 times 10 to the negative third. So that's kind of the main gist of how we use and estimate the remainder. Unique, I'm going to go ahead and address your question or your statement. What about the equation do you need me to clarify? Because I just see the whole equation of our absolute value Rn of x. Do you have any specifics that you want to clarify? Oh, I see. Okay, my bad. All right. So we only got a few minutes left. I'll go ahead and ask right now. Do y'all have any questions on our new take-home quiz or any questions that you want to ask me right now at this time? All right, I assume that seems like no. So in that case, I'll end it a little bit early. Tomorrow, my game plan is focusing more on 11.2 because that's where we dive deep into power series. And my thought process for tomorrow will be just hold problem solving sessions where we're just going to get our hands dirty and do problems on power series. And maybe tomorrow, I'll show you something epic. So with that, I'm going to go ahead and end our meeting. Thanks y'all for coming, and I'll see y'all when I see y'all.